Welcome to the deep dive. Today, we're going to be looking at, some pretty interesting stuff in the world of AI. Specifically, this family of open source language models called TÜLU. Now, I know open source and all that sounds kind of technical, but stick with me, okay? What we're going to be talking about today has the potential to, really change how we think about AI in its future. Imagine a world where the best AI isn't locked away, in some lab by a big tech company, right? It's a world where, anyone, no matter who you are, what your background is, can access and mess around with the AI and even contribute to developing it. That's the whole idea behind open source AI, and TÜLU is kind of at the forefront of this. What we're looking at today is a research paper that, goes into detail about the development of this whole TÜLU thing. And it's got tons of stuff that I think is going to blow your mind, even if you aren't a science person. You can think of this whole deep dive as like a backstage pass. You get to see what TÜLU is all about, why it matters, and what it could mean, for the future. So what makes this TÜLU so special? Well, first of all, it's not just one model, okay? It's like a whole ecosystem. Think of it like a toolbox, okay? Full of models, code, data, and all these tools, and they're all free for anyone to use, all right? This whole open source thing is really game-changing. It encourages collaboration, and that can really speed up the pace of, AI development. But here's where things get really cool, all right? TÜLU isn't just, open. It's incredibly powerful too. It's competing with, sometimes even beating those big closed commercial models, like GPT 3.5. There are some tests where TÜLU did way better than GPT 3.5. That's a huge accomplishment for something that's open source. So let's take a peek behind the curtain and see how they made this thing. The developers kind of describe their process as like a 4-stage recipe, which I think is a great way to picture it, So stage 1, that's all about something they call data curation. You can kind of think about it like picking out, the best ingredients for some fancy meal. The TÜLU team didn't just use whatever data they could get their hands on, okay? They were really careful. They gathered and refined tons and tons of data from public sources and new stuff that they made themselves, synthetic data. This focus on, using good ingredients is a key part of making a powerful AI model that works well. Then you get stage 2. That's where they take those ingredients and they blend them into a solid base. They call this stage supervised fine-tuning. This is where the AI, the model, learns the basics, how to follow instructions, do stuff like summarizing text, translations, even writing code. Think of it like the AI going to, basic training, learning the ABCs of language. Now, they didn't stop there. In stage 3, they add a little bit of human touch. They call this preference tuning, and this is where, human preferences get involved. Imagine you've got a world-class chef trying your food and giving you feedback, right? They help you make it not just okay, but really delicious. That's what they're doing here with the AI. Human feedback trains the model to create output that's not just right, but also helpful and engaging and stuff that we humans, find useful. And finally, we come to stage 4, where they add their secret ingredient. They call it reinforcement learning with verifiable rewards, or RLVR for short. And this stage, they focus on stuff with clear-cut right and wrong answers, like math problems. RLVR is like putting the model through intense training where it has to solve these tough problems with, perfect accuracy. This way, they make sure that the AI isn't just smart, but also, always reliable when it comes to certain things. So as we dig into this research, some really interesting stuff pops up. They found out that data diversity, using all sorts of different data, is super important. It turns out that giving the AI a mix of real world conversations, like from this thing called the wild chat dataset, it really made a difference in how well it performed overall. Which makes sense, right? I mean, we humans, we talk in all kinds of ways. Formal, funny, sometimes we even use sarcasm. So by giving the model all these examples of how we actually talk, it helps it learn to understand, all the little nuances of human language. Another cool thing they found was about safety, making sure these AI models are safe and, aligned with our values. That's a huge deal. So the TÜLU team, they made sure to include specific safety training in their recipe. And what they found out was pretty fascinating. This safety training, it didn't mess with the model's performance on other tasks. So basically, they managed to make a model that's both safe and really good at what it does, which is, super important if we want to develop AI responsibly. Now, they also had this interesting finding about something called overfitting. It's kind of like, imagine you're teaching a student just one type of math problem over and over again. They'll probably get really good at that specific problem, right? But then when they come across a slightly different problem, they might struggle. And the same thing can happen with AI. If you only train it on one specific thing, it might get stuck and not be able to apply its knowledge to new situations. The TÜLU team, they knew this could be a problem, so they tried to avoid it. For example, they saw that training the model specifically on math problems made it better at math. But sometimes it led to this overfitting thing, making it less flexible with other challenges. So it shows how important it is to find a good balance, right, between teaching the AI specialized stuff and making sure it can still learn broadly, so it can handle the real world, which is messy and full of surprises. So let's talk about some of these cool data sets they used to train TÜLU. One of them is called Open Assistant. This one was made by a bunch of volunteers who are all about building safe and helpful AI. It's got tons of real-world instructions and tasks, which is perfect for training a model to be a really useful assistant. Then there's this other one called Wild Chat. This one's a bit different. It's basically recordings of real people talking to AI models, like out in the wild. You can think of it as, listening in on these conversations and capturing all the weird and wonderful ways that humans actually talk to AI. This kind of data is super valuable because it shows how messy and unpredictable language can be. It helps the AI learn how to deal with, real-world conversations. But they didn't stop there. They knew they needed a lot of different specialized data to train the AI for specific stuff. So they went ahead and made their own data sets for things like following instructions really precisely, math and coding. It's kind of like a chef creating their own special ingredients to make their dish even better. By mixing these homemade data sets with real-world data, they made a model that's well-rounded but can also excel in specific areas. And this brings us back to their 4-stage recipe. Remember, it all starts with data curation. And they were really careful about this part. They didn't just hoard data. They were reviewing it, cleaning it up, making sure it was good quality. They even did something called decontamination, which sounds a bit like a sci-fi movie, I know. But basically, they made sure that the training data didn't overlap with the data they used to test the model. This is really important because it gives them an accurate idea of how well the model can handle new tasks,
which is, sign of real intelligence. Then comes stage 2, supervised fine-tuning. This is where they used all that curated data to fine-tune their base language model. But they didn't just stick to one way of doing things. They tried all sorts of combinations of data, training techniques, and even different ways of, calculating the loss during training. They were really thorough, trying to find the absolute best way to train their model. Then we move on to stage 3, preference tuning. This is where things get really exciting. They use a technique called direct preference optimization, or DPO. It's all about getting humans involved in the training process. So basically, they asked people for feedback on what the model was creating. This way, they could train it to generate responses that are not only accurate, but also, helpful, honest, and engaging. It's like having editors polish a writer's work, making sure it's not just grammatically correct, but also enjoyable to read. And to make this process even more efficient, they came up with a system for getting more of this preference data, which is a big contribution to the field of AI training.
Now, for the grand finale, stage 4. This is where they bring out their secret weapon, reinforcement learning with verifiable rewards, or RLVR. This stage focuses on tasks that have clear-cut right and wrong answers, like solving math problems. They train the model using a technique called proximal policy optimization, or PPO. It basically means that the model only gets rewarded when it gives a correct answer. Kind of like taking a test where you only get points for the right answers, right? This makes sure that the model isn't just smart, but also super reliable when it comes to specific tasks. They put RLVR to the test on some pretty challenging stuff, like GSM-8K for math and IFEVL for, following instructions precisely. And the results were, amazing. RLVR consistently made the model perform better in these areas, showing just how powerful it can be for, real-world applications. It's a testament to how clever these researchers are and a glimpse into the future of AI training, where models are trained not just to be intelligent, but also, super specialized and dependable. Okay, so we've seen how they built this TÜLU thing, right? But the real question is, does it actually work?
I mean, it's great to have a fancy new AI, but if it can't handle real-world stuff, then what's the point, right? Well, this is where the research gets really interesting. They didn't just build it. They tested it. Really, really tested it. They wanted to make sure that it's not just good in theory, but actually works in practice. So they set up 2 sets of tests, each with a different goal. The first set, they called it the development set, and they used it all throughout the development process. Every time they made a change, they ran these tests just to see how it affected the model's performance. It was like their, constant feedback loop, helping them make sure they were on the right track. But they also knew that if they only tested it on the data they use for training, they might run into that overfitting problem again. It's like studying for a test using only the same questions over and over. You might do great on that test, but what happens when you get new questions, right? So to avoid that, they had a second set of tests. They called this the unseen set, and it was like the final exam. These tests were completely hidden from the model during development.
They wanted to see how it would perform when it encountered stuff it had never seen before. And the results, well, they were pretty impressive. Not only did TÜLU do well on those development tests, but it actually blew everyone away on the unseen ones. Even their biggest model, the one with like 70 billion parameters, it did better than some of those closed commercial models on those unseen tests. That's a huge deal. It shows that open source AI can be just as good as, or even better than, those big companies' secret models. And because they shared everything, the data, the code, even how they did the testing, anyone can check their work, learn from it, and build on it. That's how we make sure AI is developed responsibly out in the open where everyone can see what's going on. But they didn't stop there. They also released a bunch of tools, including this thing called OLMIS, the Open Language Model Evaluation System. It's basically a standardized way to test these big language models. This is really important because it means everyone's using the same yardstick, so to speak. We can compare results, track progress, and all work together to push the boundaries of what's possible. They also came up with some cool techniques for, like, getting more human feedback into the training process. This is how we make sure these AI models are aligned with our values. You know, they're not just spitting out text, but actually being helpful and honest. And they shared all of this too. They gave us insights into how to curate data, clean it up, and even how to train these models effectively. So, after this deep dive into TÜLU, what have we learned? Well, it's more than just a new technology, right? It's a sign that open source AI is the way to go. It shows that when we work together, we can create amazing things that are just as good as, or even better than, what those big companies are doing in secret. And that's the future I'm excited about, a future where AI is a tool for everyone, not just a select few. So keep exploring, keep asking questions, and let's keep building this future together. That's all for today's deep dive. Until next time, keep learning and keep digging deeper.